Which of the following best explains why Na2O, so sodium oxide, is classified as an ionic compound? And then we have basically like a multiple choice. Would it be because both sodium and oxygen form covalent bonds with each other? Would the sodium oxide molecule contain delocalized electrons? Would sodium and oxygen have similar electronegativity values, or is there a significant difference in electronegativity between sodium and oxygen? Okay, well, they're already giving us a clue here. They're already telling us that Na2O is an ionic compound, right? So I have sodium, Na, I have 2, and I have oxygen. Now they are saying that this whole type of compound is called ionic. And the type of compound can give you an insight into what type of bonds this compound has. So, if we have an ionic compound, can you tell me what type of bond would be in an ionic compound? Yeah, an ionic bond. And that's because sodium is in group 1, that's a metal, and oxygen is all the way on the other side of the periodic table. Oxygen is one of our nonmetals. And the general consensus is that when a metal and a nonmetal come together, you form an ionic bond. So for the first one, when it says that sodium and oxygen form covalent bonds, that's not the case. They told us that we had an ionic compound. Ionic compounds make ionic bonds. So this one's out. Now, Na2O molecule contains a very specific wording here, delocalized electrons. When you hear the term delocalized electrons, and you're in your electronegativity chapter, this is corresponding with metallic bonding. Metallic bonding is not the same as ionic bonding. Metallic bonding is when you would just have a sodium metal, when you would just have a block of iron or a block of potassium, but not when you have a binary or any type of ionic compound. So they usually say like you have a positive nuclei swimming in a sea of delocalized electrons. Those are your metallic bonding, when you only have just a metal. So, since we have a nonmetal here, metallic bonding is not the case, and delocalized electrons, it is not. Now, it comes down to electronegativity differences. Do sodium and oxygen have similar electronegativity values, or would there be a difference between them? Well, this all just comes from where they are on the periodic table and knowing our electronegativity trend. Right? Electronegativity trend, which by the way is the attractiveness that an atom has to its electrons in a bond. But electronegativity, as we go from left to right, will increase. And as we make it upstairs, we also increase as well. Sodium is all the way over here. I mean, sodium is a metal, and oxygen is actually... No, lithium is in the same block as oxygen, so sodium is a little bit down. Sodium's over here, and oxygen probably maybe here somewhere. Maybe we'll put them as here. But they're greatly on different scales of the periodic table. One's even a metal, the other one is a nonmetal. They would have big differences in electronegativity. And just know that if you do classify as having an ionic bond, which we do have here, just know that the electronegativity difference, in order to even be classified as having an ionic bond, the electronegativity difference, meaning that if we did get the actual values and subtracted these two, it would have to be greater than 1.8, which on the scale of electronegativity is the highest realm. Greater than 1.8, you are ionic. So, that is why D is the answer. They wouldn't have similar electronegativity values because they're not close to each other. They're, metal and nonmetal, so that's good. Okay, what'd you think? Hopefully this helped. Let me know in the comments. Thank you so very much for coming here for your educational needs. My brother and I, we really do appreciate all you guys, and I really hope that you're learning from us. Let me know in the comments. Check out our website as well for more questions, glazersguide.com. It's in the link in the description, and there's cute little, ending music that has the website. But yeah, let us know. All right, I'll see you on over there, and I hope you guys are having a great day. Okay, all right, toodaloo, bye bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.